Good morning. In today's class, we are going to discuss about the Coulombs law in the form of representing in the form of vector form. So let us consider two charges, which is Q1 and Q2. In this diagram, it is considered as like charges. That is, both charges are positive or else considered as negative. Okay. So the force which is exerted towards outward direction. If it is a positive charge means the force are exerted towards the outwards, and the same time if it is negative means the force are inwards towards the charge. Okay. So here it is considered as a positive charge. The force are exerted towards the outward. So it is considered, I already mentioned it's the same charges. The distance between the two is considered as r. So let us find out F21 and F12. There will be two charges, that is two forces which are experienced along with the force. F21, which is nothing but force exerted on the charge Q2 due to Q1. Here it is F21. That is, already there may be a force which is experienced on the 2, and at the same time F21, which is nothing but the force experienced on the charge 2 with respect to 1. At the same time F12 is nothing but force experienced on a charge 1 due to 2, which is called as F12. Okay. So let us consider F12 or F21, whatever may be, the distance is R12 or R21 and the charges may be Q1 and Q2. So final the answer will be K into Q1 Q2 divided by R12 square into R12 vector. So here R12 is nothing but which is represented the direction of force. So here the direction of force is this direction. So that can be represented by these unit vectors R12 cap. Okay. Like the same, F12 vector is equal to force experienced on the charge 1 due to Q2. So F12 is equal to K into Q1 Q2 divided by R21 square R21 cap. So here the R21 is nothing but unit vector from Q2 to Q1. So one force is moving towards this direction, another force is moving towards this direction. So this is represented with the help of that unit vector R12 cap or R21 cap. Okay. So finally, it is clearly concluded that F12 vector which is equal to F21 vector, but there is a small changes in the magnitude, that is, it is negative in magnitude, but the force will be same. So finally, it is concluded that whatever may be the force which is calculated by means of Coulombs law in a particular two charges means the force will be same, but the magnitude will be same, but the direction will be different. This will be clearly concluded by this formula F12 is equal to minus F21, which is denoted in the vector form. So next we are moving towards the principle of superposition. So we all know about the superposition principle, which is nothing but the number of force, that is at a particular charge there may be so many, that is a plenty of force may be experienced. For an example, in a space we can't predict how much amount of charges will be experienced on a force. Let us assume if I am having in a charge, that is a positive charge Q1 in my hand, means there may be a plenty amount of charges which is around the our charges, that is Q1. That may be a positive charge or that may be a negative charge. Due to that, there may be a plenty amount of forces will be experienced in our charge Q1. So if you want to identify the total, or if you want to identify the overall force which is experienced in our charge Q1 in our hand, means by means of superposition we can easily find out by summing up all the forces which is near to our charges in our hand, and finally we are going to conclude that this type of amount, that is this amount of magnitude will be experienced, magnitude of force will be experienced in our charge. So the principle of superposition is to calculate the electric force experienced by the charge Q1 due to overall charges in the space, that is the charges may be from Q2, Q3 up to n number of charges. So here with the representation, that is with the help of pictorial representation, it is clearly mentioned that so Q1, which is nothing but a charge in my hand, okay, or this is a reference charge. Q2, Q3, Q4 up to Q1, these are the charge that may be exist in the space. So the magnitude may be different. For example, if I am assuming a Q1 is a positive charge, means Q2 may be positive, Q3 may be negative, Q4 may be positive, Q5, Q2 up to Qn may be positive. So whatever may be the magnitude, okay, so whatever may be the polarity, sorry. So whatever may be the polarity, whatever may be the magnitude, the final charge is experienced due to force which is calculated with the help of distance. Here I am mentioning R12 is nothing but the distance between Q1 and Q2 charges, and the R12 cap which is represented the direction, that is whether it is moved towards a right hand or left hand or upside or downside, whatever may be, that can be easily represented by the cap, that is a unit vector. Okay, so finally overall force can be calculated F1, which is the overall force equal to F12, F13 up to F1n. So these can be calculated with the Coulombs law. Q1 divided by 4 pi epsilon naught is a constant value. There may be no changes of this constant value. The only variable is Q2 R21 square R21 cap plus Q3 R31 square R31 cap plus Qn Rn1 square into Rn1 cap. Here R21, R31, Rn1 denotes the unit vector, that is the direction of force. R21 which is nothing but the force experienced in the charge 1 due to charge 2. So like the same, RT1 is also the force experienced by the charge 1 due to Q3. So finally, it is concluded these by means of superposition theorem, by summing up all the forces, we can easily calculate the overall force which is accumulated by a particular charges, that may be a reference charge in our hand. Okay. So then the important definition is about electric field. So we all know about the electric field. So electric field, it is a charge which is experienced by the force, okay, which cannot be easily seen by our naked eye, but it can be experienced by keeping or by moving a test charge, which is a new charge which is nearly moved towards the our charge. So there may be a force which is experienced, that may be a positive, that may be a repulsive force, or may be an attractive force. So finally it is stated that electric field due to the charge is a space charge around the test charge in which experiences force. So our charge will experience the force with the help of test charge. The presence of electric field, that is, if there is any charges will be presented in a space, means around a charge cannot be detected, so cannot be easily through seen our naked eye, but it can be feel by means of giving or by means of keeping on another charge which is brought towards it. So I already mentioned that if I am having a positive charge, so like the same, if I am having a positive charge which is keep more towards our positive charge, means there will be a repulsive force. At the same time, if it is negative, means there may be a attractive force. So this can be experienced with the help of electric field. And one more thing, that is, hereafter in this unit, there may be a notation called E, capital letter E. So in each and every derivation, there may be a notation called E. So E is nothing but electric field intensity. So electric field intensity is nothing but how much amount of electric field which is accumulated in a particular charge, that can be calculated with the help of electric field intensity. So which is electric field is measured in terms of electric field intensity. So E is equal to F divided by Q. So it is a vector quantity because the electric field can be denoted magnitude as well as the direction, that is where the force or where the electric field which is moved in a space. So which is expressed in the term of Newton Coulomb per minus 1. Sorry, it's the same time I want to mention that E is equal to F by Q, as well as there is another formula called E is equal to V, that is voltage divided by distance. V is equal to V by D. So there may be two formula for electric field intensity. One is E is equal to F by Q, and one more thing is E is equal to V divided by T. So at the same time, it is important to denote that the electric field intensity is otherwise called as electric field strength. So whatever may be the notation, the values we say E is equal to F by Q, that is force per charge, or E is equal to V by D, that is a potential divided by distance, and it is represented as Newton Coulomb per minus 1 R in terms of voltage.